NASA has moved one step closer to unveiling the deepest workings of the cosmos. In a milestone event that scientists have awaited for years, the James Webb Space Telescope completed its final phase of observation, delivering an image unlike anything humanity has ever seen. Just yesterday, astronomers released what many are calling the most important exoplanet photograph in history. The world captured in Webb's gaze was Proxima B, orbiting the dim red dwarf Proxima Centauri, the nearest stellar neighbor to our solar system. For the first time, we're not looking at a distant pixel or a spectral blur. We are looking at a world, a place with texture, contrast, shadow, and form. The James Webb Telescope, often considered the crowning achievement of modern astronomy, has resolved Proxima B with unprecedented sharpness. Using two of its most advanced systems, NIRCam and MIRI, Webb cut through cosmic interference and isolated the faint reflected glow of the planet itself. The result was a high-resolution image detailed enough to infer surface patterns, atmospheric density, and even the reflectivity of ice-covered regions. We are no longer imagining distant planets. We are seeing them. For decades, worlds like Proxima B existed only through indirect detection. A star's wobble, a fractional dip in brightness, a mathematical guess. But Webb has shifted humanity from inference to direct observation. This moment marks the beginning of a new era, where exoplanets become tangible, not theoretical. Proxima B lies squarely within the habitable band of its star, warm enough for water, cool enough for stability. Roughly 1.3 times the mass of Earth, it is a rocky planet, not a gas giant. Previous telescopes could never separate its faint signature from the glare of Proxima Centauri, but Webb's coronagraphs blocked the star's light with unheard-of precision, allowing the planet to stand alone in the frame. Early analysis hints at chemicals like carbon dioxide, possible water vapor, and faint traces of methane. None of this confirms biology, but all of it suggests conditions where life could exist. Temperature readings show moderated climates that, at least theoretically, might support oceans or cloud-wrapped continents. The surface appears variegated, bright zones possibly marking ice or barren landmasses, darker patches hinting at oceans or dense storm systems. The entire world is washed in a subtle copper glow from its red dwarf sun, alien, yet familiar enough to stir something deeply human. But what makes this image historic is not just its beauty. It proves what was once speculation, that we can photograph and study Earth-like planets around other stars with clarity and precision. This is only the threshold. With Webb demonstrating this capability, astronomers can now map weather on exoplanets, model climate cycles, and reconstruct atmospheric chemistry directly. Exoplanet science transitions from guessing to measurement, from theory to reality. And because red dwarfs make up nearly 70% of the Milky Way, this opens the door to studying thousands, perhaps millions, of potentially habitable worlds. Behind this accomplishment lies an immense collaboration. Optical engineers, machine learning researchers, spectroscopists, planetary geologists, and data scientists work together to decode the planet's faint light. Advanced reconstruction algorithms filtered noise and stitched spectral fragments into a single, breathtaking view. It took weeks of observations, calibration against stellar flares, and precise tracking of Proxima B's rapid orbit. The precision required was immense, but it worked. And this is only the beginning. Already, researchers are building climate maps, atmospheric models, and magnetic field estimates for the planet. If Proxima B generates a magnetic shield like Earth's, it could protect life from stellar radiation. If oceans exist, they may circulate heat across the surface. If the atmosphere is stable, life, simple or complex, may not be impossible. And now, with eyes finally on a nearby world, the dream of sending probes is no longer fantasy. Projects like Breakthrough Starshot, which plan to launch micro-spacecraft toward neighboring stars using laser propulsion, suddenly have a real, visually confirmed target. The idea of a robotic mission to another solar system is no longer imagination, it is a blueprint. Proxima B is no longer a rumor in the dark. It is a destination, a real place hanging in the night like a promise. For decades we pointed telescopes outward, hoping for more than silence. Now, at last, we have something solid. A world we can see, measure, imagine. A world we might reach. Humanity has crossed the threshold between wondering what's out there, and knowing where to go first. And so the question grows louder. What happens when we step beyond our cradle? Because every discovery Webb sends back doesn't just show us the cosmos, it shows us ourselves. Our hunger to know. Our refusal to stop. Our need to stretch beyond the horizon even when fear follows behind us like a shadow. Proxima B is the first spark on a long road. A road that may lead to new life, new skies, new chapters in our story as a species. Close your eyes and picture it, a future spacecraft, sleek and glimmering, leaves Earth behind. Cities shrink. Oceans fade. The moon drifts past like a memory. And ahead, only stars. Not for days. Not for years. But for lifetimes. A generation will be born never having seen Earth. Another may reach Proxima B as elders, fragile but triumphant. Children could step onto a world their ancestors only watched through streams and screens and dreams. That moment will change us more than fire, more than flight, more than the digital age itself. Even if the planet is barren rock wrapped in air, the journey still rewrites what it means to be human. Because the leap matters more than the landing. Reaching is what defines us. But imagine this instead. The probe lands near an ocean rimmed in copper sunlight. Sensors dip into water older than our sun. Molecules twist and shimmer in patterns that hint at metabolism, at growth, at life. Not like ours. Not built from Earth's laws or Earth's mistakes. Alien. Independent. Ancient. In that moment, humanity will finally face a truth too large for a single heart. We are not the only story. We are one chapter in a library of stars. And suddenly we will not ask, are we alone? We will ask, how many are waiting? But that future depends on what we do now. If you enjoyed this exploration into our cosmic neighborhood, be sure to like the video and subscribe, not just for information, but to be part of a moment in history as it unfolds. Webb is just beginning. It has years of fuel, years of vision, years of secrets left to reveal. Every month, new exoplanets appear like lanterns in the dark. Every spectrum is a message. Every faint reflection is a clue. And somewhere out there, maybe on Proxima B, maybe farther still, life might be looking back. Share your thoughts below. Could this planet hold oceans? Forests? Microbes under red-lit skies? Could we one day set foot on its soil and carve our footprints into alien dust? Thank you for watching. Thank you for wondering. Thank you for being part of this leap forward. Remember, each image Webb returns isn't just a picture. It's a question. A doorway. A whisper carried across light years. And as the universe speaks, one truth grows louder. We are no longer staring into darkness. The darkness is staring back with possibilities we are only beginning to understand. The oldest question remains, shimmering like a star on the edge of thought. Are we alone? Soon, we may finally know.